Welcome to our program, Astronomy for Everyone. For this show, we're going to talk about the fall deep sky objects, a little bit different than we've talked about in the past. And with us here in the studio is John Schroer. John, welcome once again.
It's nice to be here, Don. Thank you.
You're welcome. Now, deep sky objects. Can you tell our viewers what that general term encompasses?
Yeah, it talks about any type of object you can see in the nighttime sky that is outside the solar system. Deep sky objects can include stars, pairs of stars. They can include open star clusters, and these are loose gatherings of stars. There are globular star clusters, and these are globe-shaped states, gatherings of hundreds or thousands or millions of stars. There are glowing clouds and even dark clouds of gas and dust. Those are called nebulas, the Latin word for cloud. And there are galaxies, which are giant cities of stars, like the one we live in, the Milky Way.
Now, why don't we start, let's close in, relatively speaking, and work our way out. So why don't we start out with stars?
All right. There's one particular pair of stars we like to talk about. The star itself has a single name. It is Albireo. We'll bring up a chart of the fall sky, and Albireo is the head of the Swan. It's located in Cygnus of Swan, which is in the middle of the Milky Way galaxy. Now, Albireo is actually a double star, and it's actually, they have two different colors. The image we'll bring up for you here shows you one bright yellow star and one slightly dimmer blue star. And because of the state where we live, a lot of people like to refer to this as the University of Michigan double star, because its colors are blue and maize.
There we go. And of course, we know there are no green stars, so sorry, Spartan fans.
Yeah, I'm afraid that's true. There are no such thing as a green star in the sky. The blue star in Albireo is a little hotter than the yellow star, which would be similar to the sun. So the blue star would be somewhere around 40 to 50,000 degrees hot on its surface, while the golden star would be more like 10 to 12,000 degrees hot on its surface.
Now, our next grouping of deep sky objects would be the open clusters. What do we find there?
Well, open cluster stars is a loose gathering of stars. They may have formed out of the same cloud of gas and dust. And they come in a bunch of different shapes and also in brightnesses based on their location in outer space. I wanted to show one that people can see through binoculars, and it's quite attractive, and it's nicknamed the coat hanger. Colander 399 is the name of this group of stars, and you can see it looks like a slightly upside down coat hanger. Now, it's made up of different color stars, which you can see in this image right here. Here it's a line, so it's absolutely upside down. And it's very easily seen in a moderate pair of binoculars, 7 by 35 or 10 by 50 millimeter binoculars, or you'll be able to see that cluster.
Even from light polluted city skies, because I've done that myself.
Yeah, it's a bunch of stars, therefore it's intrinsically brighter than looking at a galaxy or a nebula in the sky.
What about some of these other objects that we have?
Well, the next one is M52, and we'll bring up the chart here. It's called the it's an open cluster. You can see it's in the area of the sky that you can see in the fall. It's on the left side of our screen. And if you look at the actual photograph of M52, this was taken by a member of the Ford Amateur Astronomy Club, you will also see a rather large cloud that is lit up by the stars inside. This is known as the bubble nebula. So with a good pair of binoculars or a small telescope, you'll be able to see both a cluster of stars and a nebula in the same field of view.
Now, the open cluster itself was that area just to the left side of the screen?
Yeah, that was on the left side of the screen, as you can see here. It's just on the edge.
Now, our next two items are NGC, or New General Catalog items.
Yeah, deep sky objects are categorized by what catalog they were registered as they were discovered in the nighttime sky. The most popular group are Messier objects, and they were first discovered by Charles Messier, a French astronomer who wanted to become famous for finding comets. But he kept finding these weird fuzzies in the small telescopes, and so he made a list so he would mistake these objects for comets, because if you found a comet, royalty would give you bucks for finding comets. In fact, he made his mortgage payments and paid off his house with money in discovering comets. Now, the next list was started in the 1800s. Charles Messier worked in the late 1700s, and it's the new general catalog. And it has more than 9,000 objects in it. And these tend to be further off and harder to see because they were discovered using larger telescopes than Charles had back in the 1770s and 1780s. The first one I want to bring up is called the New General Catalog 457, and it's known as the Owl Cluster because its shape reminded people of the face of an owl. And we'll go ahead, and there is the image. The two bright stars are supposedly its eyes, and then if you look upward to the right, you can see the stars that go off to the right and left acting like its wings.
Interesting.
Another one is New General Catalog number 7789. Now, this chart is located in Cassiopeia, and this is one of the three bright star pictures we can see in the northern sky. During the fall, it'll be located in the northeastern sky, and here you can see a really rich field of stars, and among that you see a really nice gathering of stars just kind of hanging out together in outer space.
That's that tight cluster in the middle of the image?
That's right.
Okay.
In the direct center of the image here on your TV, that's the actual cluster. But you can see there are many stars in that part of the sky because Cassiopeia lies in the thickest part of our own Milky Way galaxy.
Of course, Cassiopeia being the queen.
That's right. Most people see her as a lazy W. And how they ever got a queen from a group of stars looking like a lazy W, I don't have any clear idea of.
Well, if you do look at the constellation in one aspect, it does seem the side view of a throne.
Yeah,
so
but
perhaps.
imagining a queen, a beautiful queen, looking at herself in a mirror while sitting on a throne, for me, that's a bit of a stretch.
Imagination, to be sure.
Absolutely.
Well, what else do we have in the area of double clusters, John?
Well, we also have, well, you just gave it away, the Perseus double cluster. And this is one of the finest group of objects you can see in the fall sky. It's located in Perseus the hero, the guy that slew Medusa, saved Andromeda the princess from the Kraken, the monster that was sent to destroy the kingdom of Argos. Double cluster is above the head of Perseus, and it is a fantastic group of two bright bunches of stars, NGC 869 and NGC 884. If our director will be so kind, here is a wonderful image of the Perseus double cluster. And this is wonderful in a telescope, but in a really good pair of 10 by 50 or 15 by 70 binoculars, it is outstanding because you get to see both clusters and all the stars surrounding them. It's just incredible to look at.
It is. I've observed it myself, and it looks like diamonds on black velvet.
It does. It's just it's a favorite view for any astronomer during the fall.
Now, would a person be better off using a telescope to look at some of these open clusters, or would binoculars work better?
In most cases, binoculars would be pretty good. It'll give you a view of the entire area around the individual or the double clusters. Telescopes are best when you're looking at objects that are farther away or fainter. Telescopes are larger, they'll gather more light, and they'll let you see them a little better than a pair of binoculars will. But the thing about binoculars, you're using both eyes. As opposed to a telescope, most people only use one. Now, there are accessories you can get to use both your eyes through a telescope, binocular adapters. And those tend to go for at least a couple $100. And that means you have to have twice as many, you have to have two eyepieces. Every time you want to change the power of the telescope, you've got to have two eyepieces to be able to use the binocular viewer. Our frequent contributor to the show, Ken Anderson, uses a bino viewer.
Yes, he does. He's quite versed in using the binoculars.
Absolutely.
Now, these are some of the choice objects in our fall skies for our visitors to see that we've discussed so far?
So far it is, yes.
This is a wonderful conversation, and we're going to take a short break. If you have any questions, please send us an email. We sure would love to hear from you. You can see our email address down at the bottom of your screen. And after this update on upcoming astronomy events in our area, we're going to be back with the next part of this conversation, so please don't go away. Welcome back to our program. Today we're talking about fall deep sky objects, and our guest in the studio is John Schroer. Now, John, in the first part of the program, we were talking about stars and open clusters. We're going to move next to globular clusters. For our audience, what the heck is a globular cluster?
Well, a globular cluster is a group of stars that is very tightly packed together and looks like a giant globe made out of stars. Globular clusters are by far the oldest stars in the entire Milky Way galaxy, and they act like a swarm around the center of the Milky Way galaxy. They tend to be very, very old, and they're made up of, like I said, some of the oldest stars around. And there are two particular globular clusters that are really nice to look at in the autumn sky.
First one being M2, part of Monsieur Messier's catalog.
Yeah, it was the second entry in Charles Messier object. Here you can see its location in the sky. And it looks like someone took 100,000 diamonds and jammed them together on top of a piece of black velvet. That's a classic description of a globular cluster. And here's the image. And you can see how it really does pack it. It's very, very packed in the center. And it gets a little more farther apart the further you get away from the center. It's one of the really nicest clusters that you can see in the fall sky.
It reminds me a lot of M13, which is in Hercules, one of the summer constellations.
Yeah, M13 is one of the biggest around as well.
Now, you said earlier about old stars. How old are we really talking about? To the almost beginning of the universe?
No, the Milky Way is estimated to be somewhere around 10 billion years old. So the Milky Way is fairly young compared to the age of the universe, which is gauged to be 13.7 billion years old. So these stars are somewhere around 10 billion or so years old, and they're population 2 stars. Those are the oldest ones around.
All right. Well, what's another one of the interesting globular clusters in our autumn sky?
Well, to be honest, the other cluster we've got is M15. And here you can see it located in the sky near Aries, the Ram, and that'll be in the south by southeastern sky during the fall. And again, the best description is a bunch, hundred thousands of diamonds packed together on a piece of black velvet. And here you can see it's very tightly packed in the center, and as you get out further from the center, the stars get a little more loosely organized. Again, with a telescope, you'll be able to not see the entire cluster, but you'll be able to zoom in and looking at the stars near the center. With a pair of binoculars, you'll be able to see the entire cluster and see some of the stars that are surrounding it. You get a wider field of view.
Okay, but the object itself will look more like a ball of cotton than
Right.
not seeing so many individual stars.
Right. If you're using a telescope, then you'll be able to see more of the detail in the center.
Interesting. Let's move on to our next category, the nebulae.
Yeah, nebulae, those are probably best described as huge clouds of gas and dust. Nebula comes from the Latin word for cloud. And there are some particularly really nice ones to look at in the fall sky. One is actually a hangover from the summertime, but it's still pretty spectacular, and that's the Veil Nebula. It's located off the eastern wing of Cygnus the Swan, which is parked right in the middle of the Milky Way galaxy. And when you take a look at it, we'll show the image here, you'll see there the one on the lower right, it sort of reminds people of a witch's broom, which is what its nickname is. And this is actually a remnant from a supernova, a very large star that lived fast, died young, sort of like a rock and roll star, and then died by exploding and scattering its gas throughout space. This nebula happened tens of thousands of years ago, and it's still expanding through outer space. So over time, thousands of years, it will continue to get larger and larger, but it will start to dim down.
Now, our next two items here under nebulae are both Messier objects once again.
That's correct. The Veil Nebula is an NGC object, which means you need to use a proper filter to bring out the detail. But the next two were found by Charles Messier. In fact, the next one, Messier number 1, was the first one that he recorded. It is known as the Crab Nebula. And now, I should explain, it's not because it looks like a giant crab in the sky. Charles Messier was an enormous fan of seafood, and he loved crab legs. So for this, he kind of looked at it as, I'm going to call this the Crab Nebula. And what happened here in 1054 AD on the Earth, a star exploded into outer space, and the light finally reached the Earth in 1054. It was noted by Chinese astronomers who have been watching the sky for almost 5,000 years. It was not noticed by the Europeans because in 1054 they were still doing crusades to the Middle East, and learning was basically restricted to the seminaries of the Catholic Church. Native Americans in the Southwest actually noted this because it was a bright star they could see even during the daytime, and so the Chinese astronomers. It's one of the best known and one of the most recent supernova explosions that we've seen in our sky.
So in 1054 is when we first noticed the light arrive here on Earth.
Because light takes time to go anywhere.
Yes, it does.
Now the other one is located also, it's near the Big Dipper, the constellation of Ursa Major, and it's called M97, and it's got the unique name of the Owl Nebula. You can see it's near the two partner stars of the Big Dipper, Merak and Dubhe. And when you see the image, you'll see why it's called the owl. It looks just like a huge owl face made of two different colors, like staring at you from outer space.
Yeah, like a barn owl with the white face and the brownish fur
exactly
around the outside.
Now, this is not the result of a supernova explosion. This is from what they call planetary nebula. A small star, a yellow dwarf star like the Sun, died and began to throw its gas out into space. And you're looking down the throat of the nebula. It's actually hourglass shaped, and you're looking right down through the top of it.
Okay, looking through the end down back in towards the star. So that's really a line of sight phenomenon.
Exactly.
And our sun will end up like this someday?
At someday. Some say in 5 billion years, some say a little more, some say a little less, but around 5 billion years.
So we don't have to worry about selling the farm just yet?
No, not today or tomorrow. No.
Okay.
Not in this market, at least.
Well, our last category are galaxies, island universes. What can you tell and show our audience about those?
Galaxies are giant cities of stars. They were given that name by Edwin Hubble, the astronomer for whom the Hubble Space Telescope is named after. Using spectroscopic studies of stars, he discovered that if you used a certain particular star, which was discovered by a woman, Henrietta Leavitt, called a Cepheid variable star, you can predict how far away that star was by its brightness and how it changes over time. Because Cepheids are variable stars. They change brightness over time. He was able to use that as a yardstick and discovered that a bright cloud in the night sky we could see in the fall called the Great Nebula in Andromeda was actually a whole separate city of stars. The Milky Way was not in the entire universe. We'll go ahead and bring up the chart for Andromeda, the constellation, and off of her two belt stars, anybody, and even the light polluted sky, should see a small faint fuzzy hanging above the two belt stars. When you use a camera and a telescope and you take a picture, you get this. A giant spiral galaxy very much similar to our own Milky Way. Now, in the lower right center of the picture, you will see another galaxy, and that's NGC 205. If you look to the left and above the center of the Andromeda galaxy, you'll see another small, rather intense blob, and that's M32. That's another galaxy, and those two galaxies are orbiting the Andromeda galaxy. This galaxy is estimated to be about 2.5 million light years from the Earth. So you're talking somewhere around 15 million trillion miles from the Earth. Or another way to think about it, you're seeing what that galaxy looked like 2.5 million years ago.
Now, there's a couple of other Messier objects in this galaxy group that we're looking at. What's the next one?
Well, the next one's in the constellation of Triangulum, which surprisingly enough means the triangle. And it is known as the Triangulum galaxy, and it is a variant of a standard spiral galaxy. We'll go ahead and bring up the picture here, and you can see it's got a little bit of distortion to it. It's just the angle from our point of view. So it's just, we're looking at it sort of not quite directly face on, but sort of off at an angle. and it is a favorite for amateur astronomers who are going to events like the Great Lakes Stargaze next month near Gladwin.
Our last object is M74.
That's correct. And that's yet another wonderful spiral galaxy. Here it is up in the sky. It's not far from Aries the Ram. You can see some of the stars of Aries off to the left of the screen. And the image itself here is, again, it's a beautiful example of a spiral galaxy. Now, these galaxies are best seen using telescopes with the magnification power and light gathering power to really bring them into perspective and easily seen.
Now, these pictures that we're seeing, though, are time-lapse photography, and
they've taken up to 20 minutes, up to several hours in exposure time. A lot of these used to use enhanced, gas-enhanced film using nitrogen, but now most of these images you've seen have been taken using digital cameras by amateur astronomers. Some of these were taken by our own Ford Amateur Astronomy Club members.
So folks should realize, however, that what they would see through the eyepiece,
it's going to be a small, gray, faint, fuzzy. That's what galaxies look like with your eye to a telescope. You won't see the color, unless you're RoboCop.
This is quite a collection of objects to look at. I would think that any season of the year would have its collection of great things to look at like this.
Absolutely. The fall time is when you're looking not in the Milky Way, you're looking outward, which is why we have a little more variety in galaxies, extragalactic objects that we can look at. Springtime's another great time to look for galaxies.
Well, John, I really appreciate you coming here and filling in our visitors on these wonderful objects in our nighttime sky. We hope you've enjoyed the discussion. And right after this, we're going to take a look at what's up in the night sky for October. So stay tuned.
The term of the month, well, really it's a phrase of the month for October 2011, is cross-quarter days. Back in September, if you can remember back that far, we talked about the equinoxes. There's a March equinox and a September equinox. But there's also a December solstice and a June solstice. And these 4 dates break up the year into 4 quarters. Now, the quarters of the year aren't exactly the same. If we bring up the image, we'll see that as the Earth goes around the Sun, we have, we go through these quarters, but when the Earth is near the December solstice, the Earth is closer to the Sun than it is near the June solstice. So the Earth moves around the Sun faster in December and January than it does in June or July. So in fact, there are 89 days between the December solstice to the March equinox, and yet there are 94 days between the June solstice and the September equinox. Now, the cross-quarter days break each of these quarters in half. Now, there's no math that precisely defines when a cross-quarter day should be. You could divide a period in half, or you could try to do something with the ellipse or whatever. The cross-quarter days are defined by culture. And some of these cultures applies quite a bit of significance with the cross-quarter days. For example, they'll use the cross-quarter days to start seasons. Here in the United States, we use the December solstice, for example, for the start of winter. The Celts have their cross-quarter days. They have 4 named cross-quarter days. For example, Samhain is on November 1st. And for the Celts, that's the end of their calendar year. In the 7th century, Pope Gregory made November 1st All Saints' Day. So October 31st, that's the day before, is All Hallows' Eve, or Halloween. So happy Halloween. That's the term of the month, cross-quarter days for October 2011.
Welcome to What's Up in the Night Sky for October 2011. We'll start as we always do with the phases of the moon for October. The first quarter moon will be visible in the sky on October the 4th, and officially the first quarter is at 3:15 a.m. The full moon of October is on October the 12th at 2:06 a.m. Since this is the first full moon after the beginning of autumn, the autumnal equinox, this moon will be considered the official harvest moon. The third quarter moon will rise at 3:30 in the morning and be visible on the 20th. And the last phase of the month, the new moon, where none of the moon will be able to be seen because no sunlight is shining on the side facing the Earth at all times, that will occur at 7:56 p.m. It'll be located directly below the sun. With the planets, we have a gathering of 2 planets and a very young crescent moon. This will be on the 28th of October at 6:30 in the evening. You'll see a very young crescent moon on the screen to your left, and to the lower right you will see the bright planet Venus, also known as the evening star, and directly below that the very hard to see closest planet to the sun, Mercury. In the middle of the evening sky, near the constellation of Pisces, you will be able to see 2 planets. One you'll be able to see easily. The second one you'll need a good pair of binoculars or a telescope. Jupiter and Uranus are visible near Pisces. Jupiter to the lower left on your screen and Uranus to the upper right. Jupiter is naked eye visible, while Uranus, through a pair of good binoculars or telescope, will look like a faint bluish green disk. Now we're going to take you to early in the morning, approximately 4:30 in the morning. If you look to the east, you will see an orange or reddish planet, Mars. This is a close-up view of Mars, where it will be on the first day of October, where it will be inside the constellation of Cancer, directly in front of a beautiful open star cluster called Praesepe. It's Messier object number 44, also known as the beehive. By the end of the month, Mars will no longer be in Cancer, but next to the bright star of Regulus, the heart of Leo the Lion. And that's all for What's Up in the Night Sky for October 2011. Please go out and enjoy the sky. It's the best free show around.